Okay, guys, let's look at this. I've got a question for you before we get started. If I write this number, 7, cool, 7 whats? Because there could be a lot of different 7s. Like $7, okay, that's kind of cool. It's not a lot of money, but it's better, you know, maybe you can buy lunch with it or something. What about What about 7 pounds of gold? Ooh, that's worth a lot more than $7. Well, hopefully, I don't know what the current rate on gold to dollars is. Seven tigers. If you own 7 tigers, that's going to cost you a lot of money. So this is money going to you. 7 tigers are going to cost you a lot of money because you have to feed them, give them water, have a big house and all that stuff. By the way, don't own tigers. No one ever needs to own tigers. Go to the zoo. They're more than equipped to handle them over there. So why am I babbling on about numbers? Well, the thing is, when you are measuring things, you must include units. Do this. The measurement always has 2 parts. You have the value. That's the 7 part that I was talking about. Because if you just say dollars, okay, how much? Excuse me, sir, how much does this hamburger cost? Dollars. It's not going to make a lot of sense. $100, that's a really expensive hamburger. $7, okay, you may be able to live with that. And then a unit of measure. Because again, a number without some kind of label on the back end of it is basically useless. You've got some value, but you don't know what it's worth. And by the way, I will always assume something weird if you give me a number without a value. So if you say, the answer's 10, Mr. F. Cool, 10 elephants? No, 10 centimeters. Well, you didn't give me a unit. So be prepared for that, okay? So again, 200 meters, 15 milliliters, 13.98 grams. So no naked numbers. Because again, I will say something and try to be goofy about it. In chemistry and in physics, we're using the SI units to measure. This is the International System of Units. There are a couple of base units that we're going to talk about and use this year. There are meters, kilograms, seconds, and Kelvin. Those are your base. That's where you start off with. So again, we can combine them to do things called derived units. And we'll get into that a little bit more in the physics side of things this semester. So density, which we're going to talk about next week. So that's grams per milliliter. So you've got a solid per liquid. Volume, so you've multiplied distances together, and area, same thing. We're going to have a couple of prefixes. If you are a movie person, what is the story that goes before the movie? It's called a prequel. So Star Wars, all your horror movies, right? Your Halloween now has prequels in them because you're like, oh, we've run out of real story that we could have Michael Myers doing, so let's make a prequel. He's a little kid and he's got a knife and a mask. I don't know. So centi means 100, kilo means 1,000, and milli means 1,000th. So if you have a millipede, how many legs are they supposed to have? 1,000. They don't. They have less than that. A centipede is supposed to have 100 legs. Again, they don't have that many, but we just call them that, so that's a good example for you there. So we now know that we have numbers and words that have to be put together in order for people to know what you've been measuring. So the question is it better to be accurate or precise? So let's say you have a nice target here, okay? And I take my nice dry erase marker and I throw it without looking. I made a mark here. I Pick it up again, and I throw it without looking. I made a mark here. I again throw it without looking. I make a mark here. Am I being accurate or precise? You're probably saying, I don't know, Mr. F. You're just throwing stuff at a board. How am I supposed to know what you're doing? Well, accuracy means that I'm hitting the target. Precise means I'm hitting the mark mostly in the same place every time. So what if I had a bunch of marks right here? Am I being very accurate? No, it's not inside the target. Am I being precise? Yes. In fact, this is more precise than over here because see how closely together these dots are, whereas these ones are really spread out. I know they might be a little bit hard to see the actual dots on the video, but they're there. So again, accurate means capable of providing a correct reading or measurement. That's just a fancy way of saying, are you where you want to be? Okay? Every day, if you ride the bus, you want your bus driver to be accurate. Why? Because if he's not, you might get dropped off in Stowe, or you might get dropped off on the other side of town. That's no good. You want them to be accurate, that they are dropping you off at your bus stop every single, or at your bus stop. So again, that means correct. Are they getting you to your house? Yep, pretty good. So today, so here's a nice graphical representation of my throwing stuff at the board. Yeah, we're moving quickly. You're allowed to pause at any time, okay? Precise. Let's say your bus driver drops you off, 3 streets over every single day. They're very accurate? No. They're supposed to drop you off on your street, but every single day they drop you 3 streets over. That's going to be precise. So again, an exact as in perform and execution amount. Fancy way of saying it happens the same time every time. That's what precision is. So repeatable. This is more precise because we're very close together, even though this is accurate because we're within the target. Not as precise because we're more spread out. Again, that's precise. So think about it. We have accuracy and precision. You be accurate, meaning you're where you want to be once, and we have precise, that over enough time, you're getting the same results. In science, which do we want more? Accuracy or precision? Accuracy or precision? I don't know. You can pause it, but I'm going to give you the answer. We actually want both.
The freshman waited through Mitch. Please head down.
Sorry, they're doing today, and I'm not repeating this whole lecture again.
Any other freshman who has not been called yet, please go down through the commons, through the hallway, and to the auxiliary gym to be tested and get your pictures now. Thank you.
So this is not precise or accurate because everything's all over the place and it's not really by the bullseye. You can be precise or accurate and not precise, meaning once in our picture on the slide, we actually made the bullseye, the rest we didn't. And then this is what we want. In science, we want to try to be accurate and precise. So if you measure something 50 times, it's always going to be the measurement or the length that you need or the volume that you need, and it's always going to come up the same time every time. So here's the question. We have precision and accuracy. That means that we're supposed to hit a target. So what does that mean if we don't hit the target? We're still good. Great. That means we have something called error. Remember we talked about your bus driver? Eventually you're going to get tired of getting dropped off in the wrong spot. So you're going to tell somebody at home, be like, hey, I really like our bus driver, cool guy or girl, but there's some issues with where they drop us off, and it's not cool. I'm tired of either having to walk every day 3 streets home, or I was dropped off in Stowe yesterday, so it wasn't even accurate. I was dropped off at home the day before. The other day, somehow I was in Cleveland. I was watching the Indians game. I don't know how that happened. So you can have error, and we want to calculate that to see if we were accurate or what was going on. So we have called percent error. So we have Okay, so this next part has a little bit of math. I know it seems really scary, but we'll get through it together, okay? So again, how much error do we have? We were talking about being precise and accurate. So I've got a nice ruler here. It's been pre-measured out, so it should be 30 centimeters. Look at that. Okay? So I come along and maybe you say, look, Mr. F, I don't believe you. That's not 30 centimeters. Okay, I'll say, you're on. Challenge accepted. So I come through with my little tiny ruler. I'm like, wait a minute. It's like this part plus this part. So I take this part plus this part. So, okay, so I add them together, and what I get is 20 centimeters. Is 30 equal 20? I don't think so. So we're off. Are we accurate? No, we are not. Because we know we're supposed to be at 30, but we're actually at 20. So our accuracy is off. So what if you say, well, you kind of were messing around with your ruler there. Why don't you do it again? Fine. I'll show you. I know that I'm right. Okay. We got this. It still doesn't work. And then this. And then we kind of come, oh, wait, hold on. Now I could, with the, okay, 21 centimeters. So it's close enough, right? I told you I was pretty close. Again, am I accurate? No. One last time. Ugh. Jeez, this guy, teachers, I don't know, man. They always make you redo it. So, okay, so now I've got that, and I'm going to do this, and I get 19 centimeters. Again, I'm close. Close enough. I've got numbers. I've got units. Who cares after that, Mr. F? I don't care. You shouldn't care, okay? Well, think about it. Again, are we being very accurate? No, we're not. We're supposed to be at 30. But what are we being? We're being very precise. However I'm measuring it is wrong because we're not getting the right answer. However, I'm obviously doing the same way every time. So I'm being precise but not accurate. So now it's time to figure out how wrong it was. So maybe you tell me, well, that's supposed to be 30 centimeters. Oh, I see. Well, we're going to take our observed. This is what we actually observed, what we actually measured out. We went out and we took a little tiny ruler and we got these numbers ourselves. Okay? Let's just say we used 20 centimeters. We actually observed 20 centimeters. Now we subtract what it's supposed to be. $30 centimeters. So we were off by how many centimeters? We were off by 10 centimeters. Darn. So now we can take that 10 centimeters and we divide by how much we were actually supposed to have. Which means that we had a percent error of 33.33%, which would give me, if I was being graded on this, like when we're doing our lab practicums, of roughly a 67%. That's not good. So I obviously need to improve my technique on how to actually measure this, okay? Another way to think about this is your grade. If you take a test, a lot of you are familiar with that. If you have a 100 question test, and you get 90 of them right, what's our percent error? Well, our observed, or what we actually did, was 90. Then what were we supposed to have? We should have 100% right. We should have all 100 questions right. I know in this class it's not going to be a problem. This is where we're going to fall every single time. Not to worry. Which means we were 10 questions off. So we had 10 wrong. Which means we had 10% error. We were off on 10% of our questions. That's how you calculate percent error. We're looking for accuracy in science. We want to be as accurate as possible. But it's not just good to be accurate once, kind of like our bus situation. It was really awesome that your bus driver dropped you off at your house once 3 weeks ago. Cool, but if he or she can't do it ever again and isn't precise about it, then it really doesn't matter quite as much. Just kind of like if they keep dropping you off on the other side of town every single day, it's great that, at least you know where you're going, but it's really annoying that it's not very accurate. Then once we make our measurements, we have a way of telling, well, how far off were we? The word observed means what we actually measured out or what we actually did. So in our test, we actually got 90 right. Subtracted what we should have gotten and divided by what we should have gotten. And this tells us, okay, 10% of what we did was wrong. That's measurement. Remember that you need a number and a unit. So that way it makes sense, because just a number by itself could be anything. Sweet, 25 elephants. You must have a really big house. Cool. What's your pet? Do you have any pets? Dog. That doesn't help me out either. Do you have one dog? Do you have 15 dogs? Somewhere in between? I don't know. One German Shepherd is big enough, but you could have 15 Chihuahuas and takes up the same amount of space as a German Shepherd. Who knows? Okay? Then once we have our numbers and our units, we need to make sure that we're accurate and we keep getting that accurate number as much as possible. And then we'll need to figure out how wrong were we, because I'm going to be honest, guys, we're using as precise instruments as we can, but sometimes plastic rulers aren't very accurate. And so we just need to figure out how far off are we. Okay? You did a lot of note-taking this weekend. We're going to work a lot with it next week, but we're getting all this out of the way. Please come prepared with questions on everything. I'm more than willing to answer them. If you don't have questions, be prepared to answer my questions, because there's going to be questions, okay? Either they're mine or they're yours, or your classmates. So don't worry about that, and we'll work with this a lot in class. So again, hopefully your homework now is taking some notes, and then once we have a lot of stuff to work with and we don't need to take notes every night, then you have less to do. Okay, we'll catch you later. See you next time in class.